Okay, so we'd like to welcome you all to another wonderful evening of science and cooking. And as usual in these events, we start by thanking the many sponsors without whom this really would have been impossible. So our sponsors include Jose Andres' Think Food Group and the Alicia Foundation, who provided both intellectual and financial support. Whole Foods, who, as we've said many times, but I'll say again, did this wonderful thing of donating all of the food for the laboratory section of this class. The laboratory right now has become a final project fair where the students in the class are investigating various aspects of food and cooking, ranging from spherification to the making of tofu to making chocolate creations. And Whole Foods is continuing to donate food for these endeavors, and we're very grateful. So Harvard University Office of the Senior Vice Provost, Cole Palmer, who donated equipment for the labs, Le Creuset, Mars, and the Asade Business School. And without these sponsors, it literally is true, we wouldn't be able to do this. And so I'd just like to take a moment and thank them all. Okay, so today I want to acknowledge two additional groups or people that we haven't done before, just to keep things a little different. So one is, as you'll see in the moment, today, usually I'm the warm-up act, but today I'm the warm-up act to the warm-up act, because after I start, the scientific theme of the week is going to be explained to you by Professor Roberto Coulter from Harvard Medical School. Roberto, well, we're getting there, don't worry. Dave was worried there wasn't going to be an equation, but there will be an equation. I insisted, I'm doing that. But anyway, Roberto is one of the directors of what is called the Microbial Science Initiative at Harvard, and there are various parts of Harvard who have helped this course in various ways, and one of them is the Microbial Science Initiative, who has donated funds to help one of the student groups for their final projects do a DNA sequencing of microbial diversity in pork. And so actually, since we're getting to the end of our public lecture series, we have this one and one more. It occurred to me we should start thanking even other people. I hope you don't mind. Is Christina here? Where is Christina? Where is Christina? So I actually want to take a moment. So Christina, who is standing in the back, without Christina, this entire endeavor would never have happened. She is sort of she's tirelessly put together all of the preparations for these events, starting from the very first one. And as you all can imagine, this is an enormously complicated affair. And I'd like to even clap one more time for Christina, because it's really a very, very complicated thing. So, okay, good. So now, okay, so today, the topic of today, the chef of today is Dan Barber, and the scientific topic, who's sitting right there, who we'll talk in a minute, the scientific topic of today is microbes in food and cooking. So Roberto is the expert in microbes, but my job is to show you an equation and then sit down and let him talk. So here I go. Okay, so we have, as always, a theme of the week, learning objectives of the week, and an equation of the week. You can't clap yet. We have to explain the equation first. The theme of the week is that microbes play a critical role in food and cooking. They're important in how food is grown, how food is prepared, and how food is processed. And there are various aspects of this. One, biological populations, be they human, animal, bacterial, or plant, increase in size exponentially in time in the absence of constraints. This creates a demand for resources. And then microbes play varying roles in food and cooking. So, okay, so my job is to show you an equation, and I insisted, I'm sorry, but Roberto will take over soon. So here's my equation. So imagine you have a person. So, this person. So people divide. And they then became two people. And then what happens is they die off. And then you're left with two people, which is more than one person. But then those two people, they divide, each of them. Now you have four people. Then those guys die off. And then you have 8 people. So you see, that's called proliferation. And these could be people. They could be microbes. They could be any sorts of things. There's proliferation of people. OK, so there's an equation that describes that. Here it is. The number of people is equal to 2 to the n, where n is the number of generations. So you see, we had 2 times 2 times 2. You just keep multiplying by 2. And the number of generations you can express as the time elapsed divided by the time per generation. And this is how the growth, sort of unimpeded growth of populations occur. So oftentimes, scientists, they like to make things sort of more complicated for reasons that you don't even want to know. And instead of just multiplying by 2, they write it in this way, which is more complicated, that everyone's confused by. But this is our equation of the week. And it says that things grow exponentially. Now, this is a plot which Roberto criticized me for because it wasn't very high resolution, but I just took it off the web, of the population of the Earth as a function of time. And you see, it's going up very rapidly. It's been doing that for a long time. And what's clear is that this cannot continue indefinitely. Right? I mean, eventually you have a problem with exponentials. That is, you can't pay for them anymore. And we don't have time to talk about this in any detail, but if anyone is interested, I'd like to hereby recommend a book. There's a fabulous book by Joel Cohen, who's a professor at Rockefeller University, which is called How Many People Can the Earth Support? Our students will read a selection from this book this week to learn about why exponentials can't occur indefinitely. And you will see this in Dan's talk. This is really about the general issue of sustainability. So one of the things that Joel showed in this book is this table, which I think is very interesting. So the rate at which humans have proliferated has depended on the food, of course, and the way that agriculture has been grown. And so, for example, there was a transition between local agriculture, the sort of small farms, and global agriculture that occurred in around 1750 AD. And at this time, around this time, the doubling time, that is the time it takes for the Earth's population to double, changed dramatically from 1,400 years to about 100 years for the Earth's population to double. And this was because there was more food around for it to happen. And there have been other factors that led to this. So, and one of the factors, this gets back to earlier in the week, is that the new food crops that came about, that is rice, wheat, barley, and oat, had a higher caloric content per acre than the old food crops, and thus were able to support more people. And this led to a growth in population. Okay, so that's one exponential. So there's one other exponential, and this is my introduction to Roberto. So now microbes also grow exponentially. So this is a picture of a sous vide bath from earlier in this series. And someone asked, I forgot who, when we talked about sous vide baths, hey, do you guys have to worry about microbial growth? Well, the deal is if there was one bug in there, and they proliferate exponentially, then eventually there'll be many bugs. And so we're having the students think about that this week. And so I'd like to show you our homework problem for this week, and then I will turn it over to Roberto. So any of you, if you're bored, you can solve our homework problem. It's called The Danger of Exponentials, Bacterial Populations. Now let us consider bacteria. One of the purposes of cooking food is to get rid of bacterial contamination. Suppose you have a steak that weighs 0.5 kilograms that you leave sitting on a table in your kitchen at room temperature. You are unlucky, and inside your steak there is a single cell of salmonella. Under these conditions, the bacteria doubles every 20 minutes. Assuming exponential growth, show that if you let the steak sit for 6 hours, it will have 262,000 bacteria in it. That's part one. Part two is, how long will it take for the bugs to continue to grow to have the same mass as the mass of the steak? And then part three is, suppose you now take it out of the room temperature, and at the time there are only 262,000 bacteria in it, and you cook it at 60 degrees C. Under those conditions, half the bugs die every minute. How long does it take until you can eat the steak? Anyway, with that, I'd like to turn this over to Roberto.
Very good. You know, it is a remarkable thing, exponential growth. It is something that we don't always recognize. And so I know that you're here to listen to Dan Barber, but I do hope that you will bear with me for a few minutes. In the end, what Michael was talking to us, in the lack of constraints. You know, we are constrained. This is the constraint. You know, this is our planet. This is where we live. And we are quickly erasing its resources. The constraint is going to land on us very quickly. And that graph that was horribly pixelated, I don't know where you found that one. I'm sure you could have spent a little bit of time finding a better one. But there it was. I shouldn't say it too loud because my next one is equally bad, but that's not my fault. This planet is the planet where we are stuck, guys. We have to think about it. We have to think about it very seriously. What's amazing about the planet is that it's got a very, very thin crust around it that sustains life. In fact, I just landed from the airplane. I was in the Andes at 14,000 elevation, 14,000 feet. Then you recognize how thin that layer is because the oxygen goes down very quickly and it is hard to breathe. Okay. Now, life has been around on this planet for some 3.5 billion years. Us as humans, very small fraction of that. But we have managed to increase the population, and now we are facing a constraint that microbes, those that grow to be the size of a steak in a few hours. In fact, it's a useful exercise for you guys to calculate how long would it take for a single salmonella to get its progeny to be the mass of the Earth. Surprisingly, it's just a few days. So the point is, these microbes, they learned how to sustain themselves, not growing exponentially, even though they have the capacity, many, many billion years ago. And the message of the week will be, among other things, is that we can learn a lot from the microbes. But you guys are not here to learn about the microbes. You are here because you happen to live around this area. This area, and I agree, the resolution is not great, but Google Earth is Google Earth. So this area sustains about 3 million people in 2010, more or less. So that means, you know, that if we have 300 people in this room, about 1 in 10,000 of the people who live around here were lucky enough to get into this room tonight. You can clap about that. All right. Okay. Had this lecture been given a couple hundred years ago, right, when Harvard started, 250 people would have been a much bigger fraction of the total population. But we have managed to make it very difficult to get to these lectures. But why did you come? Well, hopefully you took the T at Harvard Square, and you got off, you crossed the yard, and there you are, somewhere in the Science Center. And you came here because, like me, you love to cook, you love to eat nice food, and so probably as you were rushing out of your house tonight, you prepared a quick meal where you got a chance to taste a couple of wines and maybe some cheese and bread before you put yourself a simple little arugula salad with jamón ibérico de bellota and a mousse. Right, you were just enjoying that. But maybe you should have thought about where exactly did that arugula and the potato mousse came from. Maybe it came from a remarkable place, the Central Valley in California, one of the greatest agricultural lands today. So it had to travel all that distance. Think about that. Think about the consequences of the food that you're eating, not just how wonderful it is to spherify a solution and have a beautiful looking meal, but think about where it's coming from. Where did the pigs come from? Well, they were maybe grazing in the land of Extremadura in Spain. And where did the cheese get made? The dairy farm. How was that sustained? And what about the wheat that made the bread? Where did it come from? Did it come from the Palouse out there in Washington and travel all that distance? That is what we are. So when we cook these wonderful dishes, do we think about the ingredients? Well, the beauty of it is that today we have the remarkable pleasure, the honor really, to hear from one of the remarkable chefs of our era who's really thinking about these problems. Thinking about the problems of what do you do when you have this population, pressures, what do you do about sustainability, where do you grow these things, for example, as important as the grapes that bring us this delicious wine. And you might wonder, what does this do with microbes? Well, I told you, the microbes have been around, and the reality is that not a single one of those components that I talked about is going to be possible without the soil. And the soil, if you look at a single grain of soil, it is actually covered with an incredible amount of diversity of microbes that really sustain the planet. And while we won't hear it directly today too much, I want you to keep in your mind that this invisible majority that really, really dominates the life forms on the planet are sustaining the planet. They don't care really if humans are around, but we could not be without them. And be it the cows, the grass that they're eating, or the grain, all comes through the activity of microbes. Microbes are the only organisms on the planet that are able to take this inert nitrogen that we are breathing and not doing anything with, and then they are able to fix it into nitrogen that can be utilized by all of life forms. They are producing, they are making the digestive tract of the pig able to utilize what the pig eats. They are making for us the wine, etc. So really underlying all of these wonderful things that we'll hear about is the unending activity of microbes. And that's our planet. And I'll then give it to Dan. It's a real pleasure to have you here. Let's hear about the wonderful things that you're doing out there in Blue Hill and elsewhere.
Thank you. It's very sweet. Thank you very much. Yeah, it's all right. That was a perfect introduction. I'll just tell you quickly where I'm coming from, physically, not psychologically. Stone Barns is located just about 25 miles from Manhattan, and we're growing 6 acres of outdoor vegetables, a little bit of fruit production. And we have a 23,000 square foot greenhouse, about a half an acre, that is producing about 50 different types of greens and herbs. The farm is made up also of 20 acres of pasture. We raise pigs, we raise sheep, chickens, geese, Thanksgiving turkeys, honeybees. And we're an education center for children and for adults. We have a cafe, and of course we have a restaurant. So in this kind of context, here's what I'll suggest or ask. Is there a role for a chef that goes beyond manipulating ingredients just in the kitchen? Now, I don't know how many of you have been to the talks that have preceded me. There have been some amazing chefs, the best chefs, the most creative chefs, the most impassioned chefs in the world. I wish I could have taken this course just to hear them. So it's going to sound, if you have heard these chefs, that like I'm on the other end of the spectrum. You know, I'm the purity guy. I don't believe in molecular gastronomy, the Ferran Adrias of the world, because they're all about manipulation, science, complexity in the form of this manipulation of ingredients. And in fact, the truth is, it couldn't be less true. I mean, for one thing, Ferran is curating this class, right? Is that how you would say it? So he asked me to be a part of it. So he doesn't think that, thankfully, because Ferran Adria has been a huge influence on my life, on my career, on the way I think about food, and specifically about science. I don't do a lot of manipulation in the kitchen, but I do think a lot about the same kind of underpinnings that Ferran Adrias and others who have been a part of this lecture series. The same kind of underpinnings affect me, but I'm looking at it from the ground up. I'm not as interested in manipulating ingredients when they come in the kitchen. I'm much more interested in the manipulation, and I use that word cautiously because I don't want it to take on a pejorative tone. I am interested in the manipulation and looking at the science and the choices that one has before ingredients come into my kitchen. There's a kind of recipe, if you will, for that. So let's take like a typical braised piece of lamb. You know, you would expect that I would be in a white coat here and give you a recipe for how to make that braised lamb delicious. And I could give you that, the ingredients and the method and all that. But tonight, I'd like to try and maybe take one step back and give you a different kind of recipe. A recipe from the ground up. A recipe for the recipe, if that makes sense. A recipe for the mise en place, a recipe for those ingredients to make a successful braised lamb dish. So I'm going to run through a couple of dishes. I'd like the majority of this time to be a dialogue, because I have a lot to learn. but I will talk a few dishes that have been successful in the restaurant, not because of my talent. And I spoke a little bit earlier today, and I said this, I think, in a moment of great honesty, which is like, you know, this isn't false modesty, any of this. You know, I have an ego. I think I'm a great chef.
And I think I'm really talented in the kitchen. It's just that I happen to be on a farm where I work with some of the most talented people I've ever met. And that's a humbling experience. And so it has led me to believe that the choices that I'm making in the kitchen are not quite as important as the choices that are being made, the thousands of choices that are being made in the field and in the pasture every day. And I'd like to show you a few of them. So we'll start with this braised piece of lamb. And we'll start with the lamb, with the sheep. We pick a particular variety of Finn Dorset, which is two different breeds actually that come together for two different reasons. One is they have great tasting meat. That mostly comes from the Dorset line. But the Finns are famous for the twins and the triplets, and that's good for the economy of the farm. So we make this sort of compromise with flavor and economy, which is this, I say struggle, but it's kind of a friendly struggle that's happening all the time, and you'll see it throughout this talk. And we raise them much like the picture on the left, which is to say on grass. 99.999% of the lamb that's raised in this country is raised like the picture on the right, which is in a feedlot. And it's fed almost entirely a grain-intensive diet, much like our beef cattle. I'm using lamb today, for example, because we don't raise beef cattle on the farm. We raise lamb. There's a lot of issues with this. There are a lot of ecological issues, a lot of nutritional issues. I'm just going to mention a couple here because they're in the pursuit of flavor. This whole thing is in the pursuit of flavor. I'm as much an environmentalist as probably every single one of you in this room, but that's not my shiv here. My interest is in the pursuit of flavor. I'm lucky enough that in the pursuit of flavor I've found, and I think we'll find as we go through this, that in the pursuit of the best flavor, truly the best tasting lamb, for example, that you have running along this line of the pursuit of flavor, great ecological decisions, great nutritional decisions, nutrient density, decisions that affect the health of us and affect the health of the land. That's serendipitous, and I'm very lucky to be involved in a system that rewards hedonism from A to Z, which is really what it is. I submit to you, or since I'm the professor, I'm standing behind this thing, I can tell you that the lamb on the left is incomparable to the lamb on the right in terms of flavor. I have some theories, and the number one theory is that a lamb is an herbivore. And an herbivore has what's called a rumen. And a rumen is something that all of us don't have, which is that it converts grass to energy, essentially. We can't go out and munch on the grass and live very long. They can. And not only can they live, but they can prosper. It's what their bodies want to be doing. When you're feeding them a grain-intensive diet in that picture on the right, you're actually acidifying the rumen. And when you do that, you get what's called acidosis. And when you get acidosis, whether it's in an herbivore that's a cow or whether it's in a sheep, you get kind of like a heartburn, really bad heartburn. And over an extended period of time, what ends up happening is the health of the lamb, the sheep, ends up degrading. And so what do you need? You need drugs and antibiotics, which is why our animal food system is filled with antibiotics, in the case of sheep anyway, because they need to stay alive, they need to stay healthy. And their bodies are literally breaking down because you're feeding them a grain-intensive diet. So I just put this up here, just, this is a little bit simplistic, but on a grain diet, the thinking, the thought behind it is that you really want fast growth. In order to do it, you need to import all of this grain feed, unless you're, well, wherever you are, you're importing grain feed to feed your herbivore. Again, it's an herbivore. It's not meant to eat grain. So you really are not just messing you are not just creating an economic infrastructure. You're messing with a biological infrastructure, and that rumen, I think, is at the heart of it. The energy comes from fossil fuels. Most of you know that. That depletes the healthy animals. I talked about that. Well, the nutritional drawbacks we're just beginning to understand. It's the wrong kind of fat, and a lot of theories about the connection between a grain-fed herbivore and direct correlations with heart disease. And then there's this like uniformity of flavor, which is, shouldn't be last on the list for me, but first on the list is that you get kind of a dumbed-down flavor. We have in our audience Corby Kummer, who I think is one of the great writers about true flavor. And I know he would agree with me that the best flavor for herbivores is to have them eat what they want to be eating, which is grass, a diversity of different grasses. And you're going to get difference of this flavor profile, you get a huge flavor profile in an herbivore. An herbivore, a lamb dish at Blue Hill tastes very different in May than it does in November. Very different. And for a lot of people, that's not cause for celebration because they come in November and love it, and they come back in the spring and they taste all the garlics and the onions, and it's a demonstrably different flavor. But that's part of the celebration of the animal and of the ecology. So I put this together because I think this is a pretty dramatic example, although I didn't set out for it to be dramatic. I just put them next to each other on your should I be saying on your left? Yeah, on your left is a corn-fed Colorado prime lamb. Again, 99% of the lamb that's produced, 99.9% of the lamb that's produced in this country. On your right is a grass-fed lamb from our farm. Now, what's the difference? Well, the difference is the lamb from Stone Barns is fed an all-grass diet, doesn't get an ounce of grain. The lamb on the left, I don't really know how much grass it got, but not a lot. It really got a lot of grain, for sure. And what you see, I think, from this picture is illustrative of a much larger issue. But let's be specific here. The eye of the lamb, which is to say the rack, the meat that we love so much, is about the same, right? What surrounds it is a lot of fat. So when you get to your recipe to cook this lamb, every cookbook tells you take your rack of lamb and remove the fat from the layer of top fat. That's like throwing Iowa in the trash. That's all it is. And your tax dollars are going to support a grain operation for an herbivore that's not meant to be fed grain and throw it in the garbage. It becomes a kind of lunacy that is very strange. Again, this isn't a political statement, although I guess it is by sort of collateral. It's more a statement about flavor, because the flavor that you get out of that eye versus what you get out of the eye of a grass-fed is, like I said, demonstrably different. Let me just take you through quickly what we do at Stone Barns, which is this kind of dance around the grass. We start with a field that has about 4 to 6 inches of beautiful growth, and we stick the lambs in there first, and they lead this kind of dance because they're very picky eaters. They have a taste memory that will rival any of your taste memories, and mine included. As you can see, they're searching for the sweetest grasses, the ones with the highest sugar. And they ignore the ones that don't have the sugar. And then they leave. And what follows is our chickens. The chickens come in as these sanitation ladies. They come in and they peck at the manure that the sheep have left behind. What are they looking for? They're looking for bugs. That's protein for the chickens. So they get about 20% of their diet, depending on the year. 10 to 20% of their diet is based on the proteins that they get to accumulate from breaking up this manure. They spread the manure around the field for free. And another way to look at it is we get free eggs. They also eat some of the grasses that the sheep can't get to. But I want to let's say disavow this idea that free range, this whole misnomer, free range, is probably the worst thing you can do to most animals, free range. Because if you free range a sheep, it's going to go back to the grass that has that sugar, that highest sugar content, the one that the ice cream, So what you actually really want to do, the ice cream being that sweet 4 to 6 inches. So what you want to do is, and what we do is, this is Craig Haney, who's the head farmer at Stone Barns, a brilliant farmer, and he moves the sheep in late April, May, June. He's moving it 3 times a day. When the grass slows down, he slows down the rotations. But the idea is that the sheep are getting the grass at the perfect height, which is again the perfect flavor for the sheep, and also studies have shown the perfect nutrient density for the sheep. So we don't feed antibiotics because the pharmacy is there in the grass. What we're trying to avoid is two things. First of all, what you're looking at here is what we all see in grass fields is grass that's gone to seed. That's grass that's gone beyond the 6 inches, and all of its energy, all of its sugar is pushing up to reproduce. Well, the lamb, the sheep, is avoiding that much like we would avoid like a plate of overcooked peas. It offers nothing to us. We'll eat it if we have to, but if we don't, we won't. And the idea is that once your grass has gotten to this, you're pretty much beyond the realm of having the sheep ingest ingredients or calories that are going to produce a delicious leg of lamb or rack of lamb in that case. So when it gets to this phase, you've kind of gone beyond. The idea of this intensive moving, this 3 days a week in May, is to get them quickly onto the grass that's right in front here. That's the ice cream. And the interesting thing when you go out and watch these sheep eat, and I've done this in the afternoon, is that when they like something, they go back to it. So they'll go in the morning, they'll do this kind of grazing deal, and then they'll sit in the afternoon sun and they'll chew the cud and do what they do in the shade. And then by the afternoon, you think, okay, they're ready to go off to the new grass. Well, not really. They have this amazing taste memory. They'll go back to the grass that they knew was delicious and pharmacologically was probably the best for them. Now that's the law of the second bite, and that's the critical element in the farm pasture rotation that we're trying to avoid. You don't want the lamb to take a second bite of grass that's already been eaten. Because once you do that, two things happen. First of all, you degrade the grass. The root system hasn't been rebuilt. The grass isn't healthy. And second of all, the nutrient benefits that the lamb is eating is far diminished. They're taking a second bite of grass that's already been eaten. They're getting about 1/10 the nutrient density that they would get on that first bite. So it's going to lead to a denuded landscape, but my purposes principally are it's going to lead to a denuded flavor profile. What's what we want to avoid. I took this picture because, look, these sheep are going to, in 1 hour from now, are going to move to the field that's right in front of you, in the foremost part of this picture. They've been in that pasture where they're sitting now and eating for the past day. And they're kind of done eating. They're very smart. They know they're going to this ice cream, so they're hanging out. They're waiting for the move. What's particularly interesting about this picture is that this little red canopy over there, that divides two different farms. Our farm is in the forefront. Another farm is in the rear. Another farm that is a cattle operation. Another farm that is a grain-intensive cattle operation, which is to say their young cattle are out there eating grass, but they don't rotate. This is very free range. So you would drive along the road, which is right to the right there, and you would look at these cattle out on this beautiful, sort of iconic Hudson Valley landscape, and you would say, wow, those are healthy cow. Actually, look at what they're doing to the landscape. You can see the burn spots all over the grass. What's that from? That's from manure that's been sitting in the grass that doesn't have chickens to come behind and break up the manure. In breaking up the manure, you end up not burning the grass. You end up spreading the nutrients and composting the field, essentially. So it doesn't get composted. And secondly, they've broken the law of the second bite. They've bitten second bites and third bites of the same grass. And what ends up happening is the grass doesn't come back, and you degrade the health of that particular grass ecosystem, and you get a denuded landscape. So I think that the tale of two cities here is interesting to look at. We also hay intensively, which is to say we don't wait for the hay to go to seed. We actually mow at the 4 to 6 inch level because we're feeding sheep grass all winter long. Absolutely unheard of from a percentage standpoint. You feed grain in the winter because there's no grass in the Northeast in the winter. But if you do haying correctly, and I won't have the time to go into the haying that I'm still learning quite a bit about. It's a whole science. There's a whole recipe to hay really interesting, that not only produces the best flavored lamb again, but produces the healthiest lamb that don't need any kind of medication at all because they're eating a fine diet of dried grass, but a diversity of dried grasses that are dried at the right moment. Okay, so there's the hay for the winter. And then we also, going back to this recipe for a delicious flavored lamb, we also do this sonogramming of animals that we're starting to get more involved with. Why sonogramming? Well, because we, so if 99.9% of the lamb in this country is raised on a grain-intensive diet, the sliver that's raised on a grass diet is often considered to be, what, chewy, right? I mean, you've heard that for grass-fed beef. I think you've heard it for grass-fed lamb, too. It's considered chewy. Well, in fact, it's not chewy. I mean, it's not chewy compared to beef cattle. It's just that you have this sliver of testing for flavor. 2% of beef cattle, for example, are deemed prime. So when you get a steak in a restaurant, that's 2% of the beef that's killed in this country, 2 to 3%. So when a farmer who's doing this the right way, doing this kind of rotation the right way, right way being on grass, goes to market, doesn't have the luxury of picking out 2% of the tiny 1 or 2 that he's bringing to the slaughterhouse every week. So one way to overcome this is to take a little sonogram. This and technology was invented in the 60s, on the 12th and 13th rib. That's where the grading system happens for your steak. It's where the grading system happens for the lamb. To be Colorado prime lamb, they take a read after the slaughter of the 12th and 13th rib, and they see the marbling, the fat marbleization, the fat penetration throughout the meat. And they'll grade it there. So what we try and do, what we're trying to do more of, is to grade that meat before it goes to slaughter. Because after it goes to slaughter, what good is it if you have great genetic makeup of fat distribution if it's after slaughter, right? It's dead. So great, we enjoyed the 8 racks that the 4 orders that you get out of that lamb for rack, but essentially you've lost the genetics. So if we can sonogram that 12 to 13 rib, get an understanding of the fat distribution that particular sheep has, we can then breed that sheep and increase the flavor profile through the use of this sonogram technology. We also hang it in a way that is a little bit slower than the traditional hanging of meat. The USDA has it documented that you need to, by law, chill a carcass at 32 degrees, 31.5 degrees right after slaughter. It's probably the worst thing you can do to a carcass. They get away with it because on a grain-fed carcass, picture that grain-fed, that fat covering on the rack of lamb, huge protection. It's like a winter coat. And so the meat doesn't get affected. The meat from a grass-fed animal has a very thin fat cover, delicious fat, but very thin. And if you chill it at 31.5 degrees, the meat doesn't go through rigor mortis properly. By the way, when people talk about a grass-fed steak that was tough, my bet is that it was in a slaughterhouse that by definition, by law, had to be chilled right after slaughter at 31. You shock the meat, and you don't get the flavor and the tenderness that you can get with this winter coat that most of the lambs and the beef cattle have in this country. It's a huge point. It's an unsexy thing to talk about, but it's like the thing that can dramatically influence people's conception of grass-finished beef and in this case, lamb. I want to go a little bit quicker now through cured meats. Cured meat's been around for 2,000 years. Is there a way to improve cured meats, charcuterie, before it comes in the kitchen? Charcuterie is pretty perfected in its recipe once it comes in the kitchen. It's a real art. And I have Adam Kay, who's worked for Blue Hill for 10 years, is the charcuterie master. The question is, what can we do before the pig comes into our kitchen, before it's butchered, to affect flavor? And I think there's quite a bit. And we're going to take you through that, this recipe for charcuterie in the field. Well, first of all, we start with Berkshire pigs, but we're also starting to marry Berkshire pigs with the Iberian ossibao. That has a very close relationship to a wild boar. There were pictures earlier from the professor about the Iberian pig. The reason he's showing the famous Iberian pork is that jamón ibérico is one of the most delicious foods on earth. Is from the Dehesa, from Extremadura. These are the pigs that give you that flavor, those genetics. We're marrying those two genetics together, the Berkshire pig, which has a disposition that can withstand the winter colds of the Northeast, and an ossibao that has this incredible flavor, this incredible fat distribution. And we're getting the benefits of what's called F1, which is essentially hybrid vigor. When you marry two distinct lines, you get this boost of flavor, this boost of fat distribution, this boost of efficiency in terms of conversion from feed to growth. That's a part of every vegetable growing operation and every great meat growing operation. So we're taking two distinct lines, the Berkshire and the ossibao, marrying it together for better flavor. We're also keeping a kind of CV on each of the pigs that are born. We want to know, what were they like when they were young? How much were they eating? What grasses were they eating? Did they require medication? Were they part of a successful mothering instinct? Were they, et cetera, et cetera? And we keep, when the pig comes into the kitchen, we keep a different kind of spreadsheet on that pig. We follow it straight through to its cutability, to ultimately to its flavor, which is what we're looking for. So in other words, when we taste a great pig, we want to know what influenced that flavor from the moment it was born. And we're compiling data and trying to figure out beyond genetics what can influence the flavor of your ham from the moment it's born. One of the things for sure is diet. So again, we look to the Dehesa, the king of pigs. 2,000 years of history here of feeding basically off of acorns. We don't have a lot of acorns at Stone Barns, but we have a lot of forestry at Stone Barns. We have the farm is 80 acres, about 55 of it is in forest land. So the determination of Craig, this brilliant farmer at Stone Barns, is to make use of this forest land. And how does he do it? He does it by taking this covered forest and thinning it out. In thinning it out, he then plants the grasses and forest floor that he wants the pigs to eat. In other words, he's controlling the diet of the pigs beyond just bringing in grains. Why is pigs different than sheep? Pigs are different than sheep because they're omnivores. And pigs need grain, or at least, well, they need grain to grow fat and be delicious. Okay? Maybe in 2 years I'll come back to you and say, we figured out a recipe for the forest floor that would allow the pig to be delicious with just a diversity of grasses and acorns and whatever else they can forage for in the roots. I don't think that's possible for now. We're trying to cut down on our grain bill, which comes from another farm in upstate New York, but increase the diversity of grasses. Pigs come in, they chew on this buffet of different grasses, and they're very happy pigs. Well, what do we do when we thin out the forest? What we do is take the wood. When we thin out the forest, we're creating that forest floor, that buffet of different grasses to feed the pigs. But we have a lot of wood to deal with here. Unproductive trees, not necessarily dead trees, just unproductive trees for the ecological benefit of the pigs. So we take that wood, this is a new program over the last 2 years, and we carbonize it. We make charcoal. So what do we do with the charcoal? Well, of course, we grill on the charcoal. So increasingly, my kitchen is becoming a grill fest. I didn't have grilling when we opened Stone Barns. This is a good example of how not just the flavor of my food, but my whole technique has changed because, well, it's being forced to change because the ecological conditions are telling us that there's a free resource here, and a very delicious free resource. Everyone loves the taste of grill. And if you can control the carbonization of the wood, you can actually have a whole recipe of charcoal flavors that I knew nothing about, and I'm just starting to learn. So 50% of the charcoal that we make from these trees goes right to grilling. Where does the other 50% go? The other 50% is going towards what's called biochar. How many of you know of biochar? You will, not just in a minute, but over the next couple of years. I think it's the most exciting thing we're doing on the farm right now. And here's why. We're pulverizing that charcoal. We're making it into a dust. And then we're taking that dust and we're mixing it with our compost, our soil, and planting it. It's like inserting a vitamin pack into the soil. Or another analogy, not a great one, but off the cuff, would be to take a shot of steroids. Except that the steroids last for about 2,000 years. And that's what happened in the Terra Preta, which is in the Amazon. The Amazon has, for all of its diversity, has really poor soil. But there is a strip in the Amazon called the Terra Preta, a very thin strip that has unbelievable productivity. Some of the best soil on Earth. Black dirt. We have little pockets of black dirt all over this country. Iowa, New Jersey, the Garden State was full of black dirt. Upstate New York, Warwick, black dirt country, to name just a few. There's some places in California too. Black dirt is full of biologically diverse, humus, rich agricultural land. It's very precious. Southern China, which has now been paved over, was full of this humus, this black dirt. But anyway, there's a strip in the Amazon that is highly productive 2,000 years later. Well, how did it, what's the explanation? Well, there's some debate here. And this has just been discovered in the late 70s, so they're still trying to figure this out. But essentially, there was this slash and burn. You had Amazonians who were burning the forest to essentially create new agricultural land that could support their population. Either they did it because they realized that in planting in naturally planting the burnt wood, they got this incredible growth out of it, or they just were moving on to get to virgin soil that would grow enough to support their growing population. Either way, and no one really knows for sure, more archaeologists are convinced that this was just purely accident. But what ended up happening is that the soils responded in a way that they otherwise wouldn't without the biochar, and dramatically. So that 2,000 years later, some of the most productive soil on Earth is from this burnt wood that disintegrated into the soil and added this vitamin pack. That's topsoil without biochar. And then that's topsoil with biochar. The difference is not small. Its retention of water, percentages vary, but they're huge. Its retention of vital nutrients, enormous. And now Nicholas Lyman at Cornell is the lead researcher on biochar, is discovering the capability of carbon sequestration in the soil. That this soil, because of this vitamin pack that's inserted, has this incredible ability to fix nitrogen from the air. One of the theories is that this, if applied on a big scale, can be one of the answers to cutting down on CO2 in the atmosphere. Here's a test at Stone Barns. This is not very scientific, but it's our first test, and I was amazed. You know, 'cause it's nice to talk about these things, but then see it side by side. On the left is artichokes with biochar, and on the right is artichokes without biochar. Now, the artichokes on the left are just growing at a much quicker clip, and they ended up being healthier and more delicious artichokes with the biochar than without. We're doing a ton of tests here to prove this just to ourselves, first and foremost, and then eventually, hopefully, we'll publish this stuff and get an understanding of what this can do for the future of our farm and others. By the way, this also led, maybe we could take this and just pass it around. This also led to an experiment. One of the men, Greg Twios, who is in charge of this composting operation, this biochar operation, this is like when farmers and chefs, I guess, get together, and the farmers are just come in and see a whole, come in with a perspective that just is so refreshing. And what he did is he came in late at night. He's actually a part-time firefighter for the town, and they had a false alarm or whatever. And he came through and he saw that we were dumping out the pig bones after we had butchered the pig, and after we had taken the bones and made the stock, which would end up being the sauce for our pigs. We threw out the bones. And being who he is, Greg, he said, well, that doesn't really make sense, does it? Let's see if we can carbonize the bones. That's what he did. He carbonized the pig bones, and then he went and carbonized corn. Then he carbonized lamb. Then he carbonized lobster from our lobster consommé. This is all post sauces and stocks. That's a carbonized lobster body. So now we grill lobsters on lobster bones. And what he's figured out is, this is a recipe, a whole nother recipe, again, a whole nother world, is a way to cook these lobster bones at a temperature that retains the flavor. So when you grill lobster over lobster bones, you get lobster times 2, because you're getting the aroma of lobster as it's grilling. It is fantastic. Okay, last quick example here. Greenhouse greens. So again, just dialing back. So how do you create a recipe for a great tasting salad? And also, how do you create a recipe for a great tasting salad in the middle of the temperatures that we're about to experience in the Northeast? That's the challenge. Anybody can grow a good salad in Berkeley, huh? Take you through a few steps. First of all, we're on the same latitude as southern Italy, middle of Spain, which is to say that we have essentially the same number of hours of sunlight as those European countries. We have much colder temperatures because of the jet stream, but the numbers of hours of sunlight are important if you're growing vegetables that are sunlight determinate, not temperature determinate. So our greenhouse is filled with sunlight determinate ingredients that not only are able to grow at 9 hours of sunlight in the middle of, I guess, February or January, but prosper at those temperatures. Because again, this is the pursuit of great flavor. It isn't just the pursuit of doing something that no one else has done. It's the pursuit of doing something that is focused on the best possible flavor. So there are like 3 rules to the greenhouse, and I always forget them. But I know the first one, which is that we're not growing tomatoes and mangoes in the middle of the winter. Those are temperature determinant. They need 65 degrees to germinate, and we're not interested in that in the middle of the winter. Both from an ecological standpoint, why release CO2s of fossil fuels in the air in the middle of the winter? It's much more efficient to get those from the Salinas Valley. But the second is it's too expensive. And so economy also drives that. We can't afford to grow mangoes and tomatoes in the middle of winter in upstate New York unless I pay an exorbitant fee to have them. And they won't taste very good. So here's the seedlings in the middle of the winter. Those pipes that are running below are running through with water. That water gets heated from the garbage from the kitchen. That garbage from the kitchen is breaking down into compost. As it's breaking down into compost, it's doing what? It's releasing energy. As it's releasing energy, it's trapped and coiled through the water, and it heats the water. So that, runs all the way through the pipe, so that the soil stays warm enough to germinate and grow, and then get transplanted into the greenhouse. So we do 0 heating in the seedling house, the seedling part of the greenhouse, and do it all through heating the water that's heating the soil, and the heat from the water is primarily coming from garbage from the kitchen. I think there's a second rule of the greenhouse is that we better be quick about it. So everything that we're growing, you're looking at a different kind of buffet of salad greens. There's like 30 or 40 different types of greens and herbs that we grow in the middle of the winter. And they have to go from seedling to maturity in about 6 to 8 weeks. One of the big misconceptions is that I come around and with my wand wave on the farm on what I want from my menu. It is so different than that. I don't have a choice. If the farmers, if I don't want to buy, and everything that you're looking at is bought at a fair market value, which 25 miles from Upper East Side of Manhattan is very expensive. If I don't want it, they'll sell it to somebody else. In fact, they're happy enough to sell it retail because they make more money. Luckily, I'm on a good relationship with them, and luckily, the farmers are incredible gastronomes. And so their pursuit is flavor too. I don't know if it's their #1 pursuit, but it sure feels like it. And so everything that's grown in here is unbelievable flavor. And again, it's sunlight determinant in the middle of the winter. So these greens grown in the summer taste half as delicious as they do in the middle of the winter. The other rule of the greenhouse is to make sure there's a lot of biological activity in the soil. You need really healthy soil. I'm going to take you through this very quickly. This is soil that I feel like, and I'm learning, I talked about new worlds. This is yet another new world for me, compost. I had no idea that there was such a science and perfection to creating soil gold out of refuse, essentially. And the way Greg, again, I mentioned Greg Twios before, he's also head of this operation, essentially puts this refuse into rows and cooks the soil. The interesting thing about it is that he's much like a chef. He's cooking that soil at a very particular temperature. 142 degrees is what the USDA says you need to reach as a temperature to kill bad bacteria. So every compost operation that I've learned about and visited go not just to 142, but way above. Why wouldn't you? If the USDA says you kill at 142 and you're okay after that, yeah, just kill above it. No problem. The problem, actually, for chefs is that after 167 degrees, you start killing really good bacteria. That really good bacteria is part of the makeup of flavonoids. What you end up tasting as delicious food is in that very small zone. Now, you're going to have to trust me. I wish I had a taste test for you because we've done it. And the difference in flavor, again, it's not small. What he's doing here with this Sandburger, which is an Austrian design, it is essentially taking the compost that's in the middle of this compost pile and rising quickly above 160 degrees. And he's turning it from the inside out and taking the outside soil that's not as hot and turning it in to get it hot. So he's evening the baking of the compost. Very labor intensive, very capital intensive. That machine costs $180,000. We will make back, my prediction and the prediction of Greg and others, is that we will make back this investment within 5 years just from the quality of the sale of compost, not just to our farm, but to all the other farms in the Northeast that are all of a sudden looking for organic farms and organic gardens and all the rest. We now have a contract with Whole Foods that we are selling this high-quality compost, which is expensive at Whole Foods and expensive to sell at Whole Foods, but it is worth it, and we're oversold at this point based on gardeners and landscape designers who see the value of the biological activity in a soil that's not overcooked. Huge, huge potential for growth potential, but also for flavor. We also make a compost tea, which we take that compost and we infuse it like a tea into water and spray it as an inoculant right on the plant instead of just in the soil. A lot of organic farmers do this. It creates a microbial ecology on the plant and prevents bacteria growth. This is also a test that Jack Algier, who's the head of the Four Seasons farming operation, takes care of the greenhouse and the outdoor field, is doing often. He's essentially looking at the recipe in the soil and figuring out what's out of balance. Now, I'm still trying to figure this thing out. This has been 5 years of meeting with him. And I find this absolutely fascinating. And I was walking around with my wife in the Harvard yard and just thinking, like, I wish I had concentrated in school, but I wish I had gone to school when I wasn't stupid. I don't know. I wish that I had learned this stuff, because it is the basis of the farm. It is the basis of success of the farm, not just economically, but gastronomically. That everything that I celebrate in the kitchen and that I am celebrated for actually begins here. And you know, it's a very humbling thing to admit. It's also a very depressing thing to understand. I know very little about it. And I was going to go into a little explanation, but like looking around, I better skip over this. You know, the one thing I will say that Jack, the farmer, who has a chemistry background actually and a biology background, says to me, which I think is the crux of this thing, is the cash and exchange capacity, which is in the right-hand corner. So essentially, like, you could get the recipe right in an intensive fertilizer pesticide monoculture operation in the Salinas Valley of California. You could take all the individual tests and get the right chemistry. The question is, what's available to the plant? You know, what makes it up into the plant? And that's what this CE exchange is all about, this capacity to get these nutrients to the plant. That's what's missing from a monoculture operation, why our operation is so diversified and so based on soil biology, on healthy soils. And again, dials back to that idea of cooking the soil at the right temperature so that all the nutrients, all the biology, the good biology, doesn't get killed off, and allows the plant to not only have these elements but also take it up. Which is essential for any operation, but something that is looked at at a chemistry. You come to our farm and you look at it like it's some kind of Shaker village at the turn of the century. But in fact, like, it's the opposite. It is highly modernized and highly chemical analyzed, biologically analyzed. It's just not quite in your face. I mean, I would suggest that the farm is just as manipulative of its environment as these chefs who have preceded me. And one doesn't know it because one doesn't see it. And that's what I find fascinating about the work that they do, that the recipe really for what we taste in the kitchen starts right here. So that carrot, in terms of improving flavor, that recipe that I just talked about, and the quality of the compost is shown in the Brix test. And I was explaining that earlier today. I talked to a group about the Brix level. We harvest more and more vegetables based on a Brix level. A Brix level is the parts per billion of sugar in a plant or a root or whatever you're harvesting. So we harvest our carrots based on what we know to be a high Brix level that we've gotten before. And I told the story earlier today that we hit on 1 year 13.8 Brix on a carrot. 13.8 Brix means that 13.8% of the carrot is sugar. That's very high. All of you should be gasping. When I looked at the internet for a Mokum carrot, which is this variety of carrot, it was 12 was the highest level, which means that we were off the charts. This is a much better way to harvest a fruit or a vegetable than my tasting the carrot and saying, oh, that's delicious. Let's harvest it. This is a way to document historically, year to year. And, by the way, we have increased the Brix level every year. There are a lot of variables here. Temperature has a lot to do with the cold, the northeast cold. You know, everyone talks about the growing conditions in Southern California and Texas and Florida and Arizona, but nobody can grow root vegetables like we can here because the cold converts the starches to sugars. You know, a plant physiologist who happens to be a part-time poet explained it beautifully to me. He said when you get freezing temperatures, the carrot or any root vegetable or any plant is converting its starches to sugars to prevent ice crystallization. Ice crystallization means death. So when you taste the starches converting to sugar, when you taste that sweetness, the plant is saying, you know, you're tasting delicious flavors, but the plant is telling you it just doesn't want to die. Well, Southern California doesn't have the luxury to have the plant think that it might be dying. So it doesn't convert as much starches to sugars. Unfortunately, east of the Mississippi, we get about 85% of our carrots and other root vegetables from California and Arizona in these temperatures that absolutely don't produce the best tasting vegetables. So it's one of the natural advantages of the Northeast, one of the blessed circumstances of our own ecology that we can celebrate from October through the first freezes all the way, because they store so beautifully and actually increase Brix in the right kind of storage, which I'll talk about in another lecture, all the way till May when the spring harvest comes. By the way, we did a comparison. I said 13.8 on the Brix here. We did a comparison with organic carrots that we also get into the restaurant. They happen to be from Oaxaca, that particular testing time. They're often from California or even Florida or Texas. They were from Oaxaca this time. They were organic, high-quality carrots. We used them for stocks and for sauces. And we took a Brix measurement to measure up against that 13.8. Well, what do you think we found? Thanks, bud. He already knows this story. We got 0.0 on the Brix. 0.0, which is to say that the sugars were undetectable on the Brix test. Is there a relationship between health and high Brix? I'm beginning to understand, and there's a lot of scientists who are saying there is a direct correlation between high Brix level and high nutrient value. And it makes sense because I know for sure that high Brix level and flavonoids, those flavors, have a direct correlation. And it would make sense that we're hardwired to look for the best tasting fruits and vegetables, and therefore the highest Brix, and therefore the vegetables and fruits with the highest nutrient density. Okay. I talked about that already. I just wanted to say one thing about this compost. That's heating the coils, that's heating the tubes, that has the water running through it, that's heating the soil, right? We're also not just trapping that energy to heat the water that heats the seedlings, but also to cook in. And our latest experiment after a wedding, after 3 weddings where we served lobster, all the weddings, we had an incredible amount of lobster bodies, which is to say lobster bones. We put them in the compost pile. They started to break down, and we cooked potatoes in the broken down lobster bodies as well as all the other compost, and got lobster flavored potatoes for free. The energy that's produced from this composting is quite consistent. So instead of using boiling water, we're using free energy that's also going to heat the seedlings, but at the same time infusing flavor into the potatoes, something that we're going to work on a lot more. I'm going to go a bit faster. I just wanted to talk to you about the recipe for a great tasting tomato. We've heard forever. This is a dish we serve often at Stone Barns. It's not an heirloom tomato. That's how we announce it, not an heirloom tomato at the table. I would say the name of the tomato, but we don't know, because the tomato is coming from Cornell University, a land-grant university in upstate New York, we are working with breeders who have unnamed varieties of fruits and vegetables, tomato being a fruit, that have not been trialed. They have been selected for flavor and for pest resistance. So Martha here in the corner, that's Jack Algeo, the Four Seasons farmer. You are looking at, I think, 8 to 12 different varieties this year that were all unnamed tomatoes. They are not heirlooms. They don't look like heirlooms. They actually look pretty perfect and frightening on the vine. They remind one of like a flavor saver tomato. Although they are bred naturally over 30 years with these breeders, and they produce, this is number 14. They produce very good tasting tomatoes. I don't want to say that they're better than all the heirlooms, because they're not. But they're delicious. And last year, when there was the horrible tomato blight in the Northeast, tomato and potato blight, we wiped out 98% of our tomatoes on the farm were wiped out within 4 weeks. The only 2% that made it were these unnamed varieties of tomatoes from Cornell University that are bred for disease resistance like late blight, and taste delicious and have great economies attached to them. You can see the fruit set in here. They're much better than heirlooms in terms of economy for the farmer. So we don't abandon heirlooms. We grow heirlooms. But this whole thing about heirlooms, heirlooms this, heirlooms that, it's like, you know, it's nice, but you know, it rains for 2 days and you have a terrible heirloom harvest. And what these have been bred for is resistance to disease, a good economy for the farmer, a good return for the farmer in terms of fruit set on the vine, but also you know, a resistance to inclement weather. So they don't split as easily, the skin is thicker, et cetera. I'm very excited about trialing more of these and introducing them into the marketplace. We're also introducing older varieties. Here's a celtus, which is essentially, actually right now one of my favorite vegetables. It's a head lettuce from Southeast Asia, I think Laos initially. It's a beautiful plant. We tried many years ago an experiment with carrots where we contacted a nut oil producer in California. This is an idea I got from a French oil producer in Burgundy. We contacted a nut oil producer in California. After pressing his nuts, he sent us the residue of hazelnuts. We planted it with carrots, and we got no hazelnut infused flavor in the carrot. It was a complete a failure of an experiment. But Jack Algier, the same plant physiologist who's that poet, when I told him the story, predicted the ending. He said, I'm sure you didn't get any flavor. The cellular structure, the cellular wall of the carrot's too thick. You need to try it with an onion or a fennel. And when he came to the restaurant, tasted celtus, he said, this is your guy. Very thin wall, and it'll penetrate. So Jack pulverized hazelnuts, planted it with the celtus. And we did get hazelnut celtus when you broke the celtus open. To be honest, it actually tasted a little bit more like pine nuts. But we got like a nut flavor. So I considered that successful. We're going to do a lot more of this gentle genetic modification. It's not genetic. It's a gentle modification that takes refuse, in this case nuts, which came from California. But you forgive me for that because they're very potent, and this idea that we could infuse flavor in the ground is very exciting to us. Okay, so let's end here, and I do want to open this to questions and comments and all of that, and kind of maybe make this into a little bit of a broader discussion other than science, although at the base of all of this, as I've argued before, this is science. But what's the role of like a chef, or I should have said, like, what's the role of a chef or anybody who cares about food, who likes to eat, you know? Well, yeah, but there are not a lot of us out there, you know? There are people who eat, and then there are people who just eat to be full. I'm talking about the people who eat because they see food as part of the pleasure of living, and I'm talking about the chefs who are constantly in search of the best possible flavors for their repertoire, for their recipes, and of which there are a lot of them. A lot of them are a part of this course. There are a lot of chefs out there. That's what we do. My suggestion is that through all of this, there's a bigger role for us to play in the future. And one of the inspirations for me is someone who's in your neighborhood here, Dr. William Lee. Dr. William Lee is the president of the Angiogenesis Foundation. The Angiogenesis Foundation is a look at cancer prevention through capillary growth that feeds tumors. There's a lot of science going on with this right now. Dr. Lee's interest is in looking at cutting off the flow of blood to tumors through diet. In other words, prevent cancer through eating fruits and vegetables, and particular kinds of fruit and vegetables. What he argues, quite brilliantly, and you can look him up, you can look up his talks, he talks frequently. What he argues is that cancer is 90% environmental. And of that 90% of environmental factors that cause cancer, a third of those have to do with diet. That we know. So is there a way to starve these capillaries that feed tumor growth? He identified the fruits and vegetables that have the highest anti-angiogenesis levels through years and years of research. Those are what he determined to be the highest levels, the levels that literally prevent the feeding of tumor growth. And what he showed is that the modern cancer drugs don't really do that much better than the identification of these fruits and vegetables. That you can actually eat a diet that is commensurate in terms of preventing and restricting this capillary growth, that is commensurate to the best drugs available on the market. Here's one test, and I think we'll just end with this to tie this up. But here's one test where he took jasmine, sencha, Earl Grey tea, and compared them in terms of anti-angiogenesis. Again, the growth of the capillary growth that feeds these tumors. And he was expecting jasmine, because everyone talks about jasmine as being the great cancer tea. He was expecting jasmine to be quite high and sencha to be even higher potentially. What he found is that Earl Grey actually, as far as this capillary growth, that Earl Grey had almost double and triple the potential of a green jasmine, of a jasmine tea. Here's what I found most interesting about what he talked to me about, is that quite by accident, he mixed the jasmine and the sencha together. Now you would think the blend might be double. I don't know what you would think. He was thinking it would be about what sencha was, maybe a little bit higher. What he got was more than double the anti-angiogenesis benefits from this mixing of these two teas. Now what that said to me is that at the end of the day, this is healthfulness. The pursuit of flavor is about cooking, as well as this pursuit of the chemistry and the biology that's happening in the field. It's about cooking. It's about the mixing of different ingredients. So what I said to him is two things. First of all, when you have this list of these highly potent, this list of ingredients, these parsnips and grapes that have high anti-angiogenic properties, have you ever tested how they're grown? Like, what about a parsnip that was grown with the kind of compost that keeps within 142 and 167? I can tell you that the parsnip has a higher Brix level, and I can tell you the parsnip's much more delicious. Can he tell us that the cancer-fighting properties are correspondingly higher? His theory is yes, and he has not done those tests yet. So he is now getting vegetables from Stone Barns, from Jack Algier, and testing them, identifying them for these properties, and trying to show, or not show, he's a real scientist. I always have an agenda here. He's the real scientist. Is there a relationship between Brix level and cancer-fighting properties? There probably is. And not only that, we're going to eventually, the second phase of this trial, and he's again, the real scientist, he's taking this very slowly, but the second phase is some of the more successful dishes I've had in the kitchen, which is to say the combination of ingredients that have led to people thinking the food is really delicious. I have a slew of these recipes, a slew of these dishes. Is it also true that these dishes correspond to not just the best tasting flavor, but the best nutrient density and the highest possibility for anti-angiogenetic properties? Can our most successful dishes also fight cancer? It's a big proposition. But my intuition, and I'm sure the intuition of everyone here, is that there has to be a correlation between mixing things that are absolutely delicious to us, things that we want to come back and have more of, whether it's a carrot or the lasagna from your grandmother or a dish at Stone Barns. There has to be a relationship between that pursuit and the pursuit of great flavor and the pursuit of great health. So this is the direction that we're headed in at Stone Barns, not just working with these breeders, but working and expanding the role of chefs and food lovers to transform and manipulate, again back to that word, manipulate the way the ecological landscape is used. I think it's a very exciting future, and I hope you'll be a part of it with me. Thank you.
Okay, so with that, there's time for some questions. There are mics roving around the room. I see Jen has a mic.
So you mentioned you were talking about the FDA guidelines for chilling lamb.
Yeah.
You said the guidelines were detrimental to the quality of the lamb, essentially when you were doing grass-fed lamb. Is that correct? Okay. So how did you guys get around that? I guess is my question.
Yeah, well, you know this is being filmed, so. Look, I'll answer it this way, which is to say that, you look at pictures of Argentinian slaughterhouses. I haven't been to Argentina, but I've been shown some really interesting pictures. And everywhere you look after slaughter, you see this kind of corridor of this kind of hallway in every slaughterhouse. They look somewhat different, but essentially it's the same idea. Windows are open, carcass is still warm, and it's chilling down slowly. The Argentinians know this because they don't feed grain, they feed grass. They have the best grassland in the world, and why some of the best steaks in the world come from Argentina. But those carcasses are entering into rigor mortis at levels that are much more conducive to tenderness. People say tenderness is associated with corn. It has nothing to do with it. It's all about temperature. This was proven in the 70s. You can go on to, where can you go? Joe Robinson has done the best. Look up Joe, just Google Joe Robinson. She does the best. She's actually, she's a scientist, but she's also collected some of the best data on this, on pasture-based herbivores and other animals. And this all started with the spike in grain prices from the then USSR. And they were looking at this stuff and seeing that you couldn't chill the animal if you couldn't afford the grain, you were feeding more grass. This is in the early 70s. This is what historically in recent history, this is what really started the whole pasture-based movement. When we moved, World War II started the grain-intensive movement because we figured out the technology to grow monocultures of corn. And when you ended up having too much corn, you ended up dumping it into herbivores and into processed food, which has become a big part of our diet. But in the 70s, when there was that spike, the price parity for grazing animals on grass was pretty commensurate with grain, and that's where you get all these hippies in upstate New York, around the country, who started just this pasture-based system, who are still alive today. We buy from John Jameson a lot of lamb from John Jameson, who I think is one of the great grass-based lamb farmers in the country, if not beyond that. He started just when grass was becoming too expensive. And he was also, a Woodstock guy from, who didn't want to be under the chains of the grain. The problem he discovered was that all the slaughterhouses were chilling at this USDA. Well, how did the USDA get to a number of 31.5 within 2 hours or whatever it is? I'm not even sure. Well, it's one size fits all. It's it's written that those laws by big agribusiness, by the Cargills of the world, who don't want the competition from the grass-fed and want faster chilling, and the slaughterhouses want faster chilling because they want to move product. So it all works in the say. The problem is it's the worst thing you can do to a grass-fed. You can have the right breed, the most perfect grass. You can move it 17 times a day, and have the most incredible fat distribution in that 12th to 13th rib, and you can ruin that lamb or that beef cattle in 40 minutes by bad chilling. So again, this is the unsexy story of this whole thing. Is the problem is the slaughterhouse issue. Is in the Northeast we don't have any more slaughterhouses. So the slaughterhouses that we go to, we end up paying a lot more to process these animals, these grass-based animals, in a different way. And not only not only is the incentive to move animals through the system quickly, because now even on a local community level, there's so few slaughterhouses, there's absolutely no incentive to slow that down. I mean, they're just making money now to survive. And that's the huge difference over just 15 years ago. But beyond that, the knowledge has been lost because everything we do is grain-based. So, you know, it's a huge issue. It's hard to talk about because, again, it's post-slaughter, and it's these very sort of finite kind of like ephemeral issues. But when you look at it from side-by-side taste, it's huge. And this reputation that always galls me. When I always get it, it's like, oh, you have to chew and chew for the grass-fed steak. No, you don't. No, you don't. If you raised it right, and you slaughtered it right, and you hung it right, it's like butter. As my grandmother would say.
You mentioned, is this on? You mentioned the lack of slaughterhouses, especially in the New England area, New York area.
Yeah.
Have you seen a change in the past, say, 5 years of infrastructure for the small farms, which is what we'll have in this area to be successful?
Yeah. No, it's a great question. The answer is no. The change has been even more depressing. But to put a positive light on it, the reason I say it's depressing is because the Northeast, this is low-hanging fruit. You know, for everybody who wants to get into farming, and there are a lot of people who do, based on the success of the farmers market and based on the Michael Pollan and the Corby Cummers of the world who are writing about all these issues for so many years. It's the most exciting social movement in America today, and for the Northeast, the most economically viable agriculture is animal-based, which drives me crazy when people, you know, talk about vegetarianism and where we're sitting. It's like this whole ecology was built on grass. We have the best grass in the country, one of the best grass systems in the country. And that's why all the dairy farms are in New England. It built New England. It built our iconic landscape. And we ought to be taking advantage of it. And you can really easily, if you're interested in these issues, you can really farm at a sustainable level, and I'm talking about economically, a very small herd of sheep or cattle with not a lot of grassland. If you're intensive about moving it and you can raise it the right way and you can actually get it slaughtered, there's money to be made and there's a market for you. You don't have to go through the middleman. There's a market waiting for you, both through chefs who are intent on, I think chefs are leading this movement, but also through farmers markets whose numbers are exploding. But the problem is when it gets to the slaughterhouse level, which is what you're asking, have they been increasing in commensurate in parallel lines along the increased demand? The answer is no. They've been going the other direction, which put more pressure on slaughterhouses that are around. And again, they've become very sloppy. And I don't blame them. If I was owner of a slaughterhouse, I was third generation, I just wanted to hang on for my children, I'd be moving as much product as possible through it. And the skills of the butchery, the skills of the processing, the skills of the chill have gone downhill. The bright side of this is that we are in a transition period. And again, the costs of bringing a grain-fed animal to market don't represent the true costs, both to our economy, both to our ecology. And when those true costs happen, and I really believe that we're entering into a period where grain's going to become much more expensive because fuel prices are going to become more expensive because the ecological services that produce that grain so cheaply are not going to be there. When that starts to happen, and we saw it a little bit 2 years ago when oil was $135 or $138 a barrel, but we're going to see more of it in our lifetime and certainly in our children's lifetime. The necessity of having these slaughterhouses locally is going to be there. And just I was saying the bright side, it took me a long time to get to it. The bright side is that there are these roving slaughterhouses which are now on 18-wheel trucks, essentially, that bring the slaughterhouse to your farm and actually drive it out into your field. A lot less stress on the animal. The slaughterhouse comes to you, it slaughters the animal, and you hang it yourself, and it leaves and goes to another farm. The economics of it that I've seen, and I've been looking at one particular operation really closely, is brilliant. And the community, what do you call it, the community support of that versus building a slaughterhouse in your backyard and depress home prices is like a lot better. So I think this is kind of the wave of the future, and it's not so bad. It could be actually really great.
I had actually thought about making my own charcoal one time, and I was just wondering if if you're planning on sharing not just the charcoal techniques, but all the various techniques that you've talked about.
Yeah,
you, like,
man,
publish
we're
on
an
the
open
web,
book,
or?
dude. We're not hiding anything. We're still learning. I mean, yeah, come to Stone Barns. We'll teach you everything. I don't know anything. These guys are doing it. The main thing I'm trying to get them to do is cook the charcoal at a lower temperature to preserve the flavor of the lobster body or the wood or the lamb carcass, and get that flavor to infuse into what I'm grilling. And they have a lot of problems with that, both from a microbial perspective and also from a time perspective. But come and be a part of it, because it's really exciting.
Is there like a website or something that you guys are sharing?
Not yet, man. No. Yeah.
Can you tell us about anything that's going on with fish and
Yeah.
what you might be doing differently?
Yeah. So I'm very excited about, what am I excited about? I'm excited about this particular farm in Spain that I've been talking a lot about, called Veta La Palma. It's in the southwestern corner of Spain, at the tip of the Guadalquivir River. And it doesn't feed its fish. It essentially uses the natural resources of their ecosystem that they've built up, this biology, essentially. They plant biomass, which is what feeds the fish, and produces this unbelievably delicious flavored fish. We get a lot of that fish in now. That's been our latest success over this last year. We've been able to import it. We found somebody brilliant fish importer who saw the brilliance of this system and the flavor. Again, the flavor. And you know what's funny is, like, I went to 2 fish importers. I've talked about this farm for the last 2 years. I'm writing a book in principle about this fish farm, because I think it really is illustrative of an example of what the future of agriculture could look like, working within a natural system to basically feed animals for free and produce the best tasting food, and not only preserve the ecological integrity of the place, but improve it along the way. It's a great example. But I couldn't get these fish importers to see the brilliance of it, in part because it was so expensive, and in part because it was just, I guess, a hassle. I got to one who did, and what's so interesting is that it is the hottest fish in New York right now. And I don't know how many of you know these restaurants, Per Se, Le Bernardin, Jean-Georges, Daniel. The top restaurants have flooded to this fish, whereas I am now not the largest buyer of them. These other, who have more market power than I do, are buying it, which is great, and spreading the word based on flavor, which I think is the bigger issue here. You know, I could be talking about these issues through the perspective of the environmental benefits of this kind of fishery or this kind of pasture management. But I think the best way is through flavor. And that example proved to me, I mean, the story of this farm proved a lot to me. And it made me more infatuated and impassioned about the work that we're doing at Stone Barns, and more impressed with our farmers. But even more than that, it showed that without anything, these chefs tasted this stuff and don't care the cost. And they're flooding to it, and they're fighting over it to serve it at their restaurants. They don't know about the ecological benefits. They don't know about the health issues related to this kind of fish. They know about the flavor. And that's why I believe so strongly that chefs and foodies, people who love and care about food, foodies are the future of the world. We're a lot easier to feed than the fast food world. A lot less ecologically impactful, and a lot cheaper, essentially. And when all the costs are calculated, a lot cheaper. And that's why we're going to lead the most exciting social movement in America for the future, because when the real costs of the big food chain get calculated, and they're going to get calculated, our system, the system that we all believe in and want to feed our children and want to eat ourselves, is going to become de facto. Big agriculture is dead, and big fishing, in response to your question, is dead man walking. They're never going to be able to support it, both because there's no ecological resiliency for it, and the cost, just the fuel cost of going out on these trawlers to wreck marine ecosystems is not going to be there. So whether you believe in it or you petition your Congress, whatever it is, it's the economics that's going to end up destroying that. And I believe the same thing for corn agriculture. I believe the same thing for grain-fed beef. I believe the same thing for monoculture carrots from Oaxaca. not going to afford to be able to do it. So there's beauty in this grassroots movement. I believe this is bottom up. Obama taught us that, the effects of a bottom up movement. It's very inspiring, and in America it has this potential to change the world. I think that's going to happen with this movement, and I'm a betting guy. I'm betting on this movement. A lot of people say to me, "Aren't you at the cusp of this? I mean, isn't this is the height of this like local organic thing, isn't it?" They are so out to lunch. This is just the beginning. This is the beginning. I haven't seen anything.
There are more questions, but that was such a fabulous ending that I'd like to propose that we clap one more time. Especially the students of the future of the world. And thank you.